Recording in progress.
So good morning from the Hellenic Mediterranean University. Even though that I'm in Athens, I'm representing the Hellenic Mediterranean University, the Athena talks, the HMU International Relations Office Chai Cafe talks, and it's a great honor to have with us two guest speakers. First of all, we would like to thank Mirella and Professor Koudumas for bringing these people to our university. This helps our university to network and also network our scientists in the specific topics that Hossam and Yasser will present. A few words, today's talk title is Design and Implementation of Advanced Water Treatment and Desalination System and Advanced Studies on Photocatalytic Activity of Hybrid Nanomaterials for Different Environmental Applications. I suspect that particularly for Crete, this is like a crucial topic since because of the climate change, we have some kind of shortage regarding our water reservoir, but also it's very important to learn from Hossam how we can exploit and leverage, the seawater around us, if I'm right, using the desalination systems and methods in order to leverage this for various purposes. So I will speak a few words about Professor El Nazer. Professor Hossam El Nazer is a professor of catalysis water technology at the National Research Center in Egypt. Professor El Nazer has an excellent expertise in the application of catalysis in the environment and industry and the design implementation of water treatment and desalination systems. Is the principal investigation for many national and international joint venture projects concerning water treatment and desalination. He has supervised many master's and PhD theses in the topic, and he has more than 30 publications, research articles, book chapters, and reviews. More about the Google Scholar or the academic scholar profile of Professor Nazer, you can find it through our Athena Talks website. And now I will provide the floor to Professor El Nazer, and later on I suspect with Yasser. I don't know how are you going to coordinate your presentation. I will provide you the floor, and I would like to thank you on behalf of the Hellenic Mediterranean University and the Athena European University for your contribution. So please share your screen and start your presentation. You have 45 minutes, and then we are going to have the questions. Thank you very much, both of you.
So, do you see the presentation?
Yes, we can see the
Yeah.
presentation in full screen.
Okay.
Thank you.
Yeah. Okay. Thank you. First of all, good morning, everybody, ladies and gentlemen, my colleagues, professor. Before I'm starting my presentation, I would like to thank Athena European University for their kind invitation and for giving me this opportunity to present my research work. Also, I would like to thank Hellenic Mediterranean University for their kind invitation to visit the university. And actually, we have good and wonderful meeting and agreements concerning water treatment and the agricultural science. Now, let me introduce myself. I am Professor Sam El Nazer, Professor of Photocatalysis Water Technology at the Chemical Industries Research Institute at the National Research Center in Egypt. I am here today to talk about design and implementation of advanced water treatment and desalination system. And before I start my talk, let me introduce my research institute, the National Research Center in Egypt. National Research Center is considered to be the largest multidisciplinary research R&D center in Egypt, devoted to basic and applied research within the major fields of interest. It possesses an impressive scientific technological infrastructure and manpower resources of more than 4,800 research staffs, students, professors, and researchers. It also consists of 14 institutes and 109 departments covering the major areas of industry, health, environment, agriculture, and engineering. Now, let me discuss with you what is the future perspectives for water treatment and desalination in Egypt. Actually, the Egyptian government and state has developed a strategic plan to increase the agriculture area and reclaim lands. Uh, we have the available water in Egypt is only 55 billion meter cube of good water or fresh water per year, but the the needed is more than 80%, 80 meter cube of good water. So we have a gap more than 25 billion meter cube of the water. So we are in dire need of other water resources. So researchers and scientists in Egypt put great efforts to find a suitable and appropriate way to save water and to develop a new and low-cost technology for production of good water. So we have developed a strategical plan in Egypt 2020 to 2050 that has been put to expand the implementation of water treatment reverse osmosis desalination plants during the next 30 years. And we have put also great investment that have been suggested to be implemented in 5 years of plans, each of which has a 5-year implementation period. So reverse osmosis technology and reverse osmosis desalination technology has been supposed to be the most appropriate and efficient way to have desalinated water. Since in Egypt we have a large amount of groundwater, especially in West Desert, in Egyptian West Desert, but the main problems of this water is the high salinity of water there. Actually, we have made a lot of environmental geological study to evaluate the quality of water there, and we found that the salinity exceeds in many places 4,000 ppm, and in other places exceeds 10,000 ppm. So this is salinity are very high and very detrimental for irrigation and for agriculture. So what are the barriers to use and introduce RO desalination technology in Egypt? The first barrier is the cost. Cost is a principal barrier to greater use of desalination reverse osmosis technology, since the cost of producing 1 meter cube of desalinated water after the stage of operation, maintenance, and production ranges from 12 to 15 Egyptian pound. Also, we have problems with our reverse osmosis membrane costs, fouling, and we have also scaling problems. So, my research work in the National Science Center aim to first fabricate low-cost, efficient material like antibacterial, anti-fouling, heavy metal removal. Second, develop a reverse osmosis batch unit with cooperation with different universities. For example, we have a good cooperation with Birmingham University to design and implement low-cost desalination unit, and this unit will save 40% of the energy used in similar station. Third, to reduce the cost of production of 1 meter cube desalinated water from 12 to 15 to 7 to 8 Egyptian pound. So this system could serve farms, village, resorts, and north coast, as well as those located on the Red Sea coast. Now, our desalination system comprises of two main units, pre-treatment unit and RO unit. So we are working in two axes. The first axis is develop pre-treatment system and the materials, and the second axis is develop reverse osmosis batch technology, batch reverse osmosis reactor, which could save more than 40% of the cost for producing 1 meter cube of desalinated water. Regarding pre-treatment unit, we have succeeded in synthesis of some advanced hybrids for bacterial removal as antibacterial, heavy metal removal, water hardness removal, dissolved organics removal using suitable and efficient photocatalysts. Regarding the RO unit, we have also, with the cooperation of Birmingham University, we have succeeded in design and implementation batch reverse osmosis system with low cost and efficient system. Also, we have worked in synthesis of RO membrane itself. So the aim of pre-treatment in our system, pre-treatment stage of our system, is to decrease the contaminant, to remove heavy metals, to remove these dissolved organics before the water entering RO. So this will increase the efficiency of RO system and increase the lifetime and durability of RO membrane. Now, so let me discuss with you the activities and achievements concerning water treatment and desalination work. We have a lot of meetings and online Zoom meetings and workshop with our colleagues in Egypt and our partners from other countries like UK, Greece, Italy, and USA. Also, synthesis and the characterization of and evaluation of antibacterial materials and RO membranes and photocatalysts. Third, design and implementation of photocatalytic RO unit. And now I would show to you some examples of our research articles that have been published during the last year. I will discuss now the article entitled High Potential Removal of Copper 2 Ions from Aqueous Solution using Antimicrobial Cross-Linking Grafted Gelatin Hydrogels. In this paper, anionic cross-linked gelatin hydrogels were successfully prepared via free radical polymerization method using different concentration of methylene bisacrylamide, ranging from 2.5 to 10% as cross-linking agent. As we know that gelatin is polymer based on proteins, and it is a natural product and a very cheap product. And we use modification of this gelatin to form synthesize very efficient hydrogel, which could absorb copper ion from wastewater, and also it has antimicrobial efficiency to remove bacteria and the microbe from wastewater. And you see the scheme for absorption mechanism of copper ions on the cross-linked hydrogel, and we see here from the scheme we have a coordination bonds between electrostatic bonds between the positive copper ion and hydroxyl radical, which are on the surface of modified hydrogels, and we have a good efficiency of removal copper ions, which exceeds 87% removal of copper ions present in wastewater, and also we have 100% efficiency to remove bacteria and microorganisms present in wastewater. Now, let's go to another research article which have been published in scientific reports, which is a part of Nature publisher. And this article on facile synthesis of ketosane grafted polyvinyl pyrrolidine functionalized multi-wall carbon nanotubes for application in copper ions removal and bacterial growth inhibition in aqueous solution. And we have also in this paper succeeded in synthesis and preparation of high efficient hybrids from carbon nanotubes and ketosane. Also we have a good findings and the results with using this composite. We have also more than 90% of removal of copper ion, and we see that this is a mechanism of introducing vinyl carbon and grafting vinyl pyrrolidine on ketosane, and we know that ketosane is a polysaccharide material polymer. And we see that we have a lot of N groups here and here and here, and these N groups have a good ability to absorb copper ion. And when we put carbon nanotube in this grafted ketosane, also we the carbon nanotube increased surface area, and also carbon nanotube could absorb both ketosane and copper and increase the efficiency, and we have an efficiency more than 95% of removal of copper, and also an inhibition of the growth of bacteria in wastewater. And now I will discuss another research work of our research group entitled Highly Selective Visible Light Triggered CO2 Fixation to Cyclic Carbonates under mild condition using titanium-based multi-wall carbon nanotubes grafted with platinum or palladium nanoparticles. And I would like to say that I actually started this work with my partners in Italy, with a photocatalysis group in Palermo University, since 3 years ago. We have succeeded in preparation of titania loaded with platinum and palladium nanoparticles using photo reduction technique, and we succeeded in using these photocatalysts in the photocatalytic degradation of some sugars and production of hydrogen as a byproduct. But in this research work and paper, we upgrade and improve the photocatalyst, and we put multiple carbon nanotube and grafted to the titanium doped with platinum and palladium, and we have good photocatalysts which have higher activity. Also, we applied this photocatalyst in a reaction of transformation of styrene to oxide to available compound carbonate derivatives. Also, we introduce the carbon dioxide to styrene to produce polycarbonate. So we have two targets. The first is transformation of styrene to polycarbonate. Second is fixation of CO2 to the styrene compound to form a valuable compound of polycarbonates, and we have prepared many derivatives. And as we see, the yield in some cases exceed 98%. So this is good yield. Also, we have also field studies during our research work. One of these studies have been performed in the framework of UK-Egypt Science UK-Egypt joint venture project. We have a joint project with Birmingham University during Newton Musharrafa program for design and implementation of low-cost desalination RO unit. And we have started our research work with some environmental geological study. We choose some areas in Egypt to study the quality and to make evaluation of the groundwater there. And we choose Siwa Oasis zone in the West Desert in Egypt. Siwa Oasis is one of the most promised location in the Western Desert of Egypt for future agriculture project as a result of groundwater availability, but the salinity of water makes it detrimental for irrigation. And within our study, we have find that the salinity in this area exceeds 4,000 ppm, and in many places in Siwa, we have found that the salinity also reached 10,000. So we have built our study on the quality and the evaluation results of the water in Siwa Oasis. And this picture shows our have been taken while we are in some environmental geological study, while we are taking samples from water from different zone. And now you see in our this is our site where we have designed and implement our desalination unit, and this is considered to be a technological site in our NRC National Research Center, and this site is located at the 6th of October city in Cairo. And this is a technological branch of NRC. Since we have the main branch and the main building in Doki Giza, and we have a technological branch in 6th of October, and this is our site where we implement our water treatment and desalination system. And this is a picture from the system that we implement in our site there. And this is also some picture. And this is a video show the running of the system. I'm sorry. I will show it again. And we see here the system, and we see this is a photocatalytic reactor, which is built in a pilot scale, and where we put our photocatalyst here in this reactor, and the photocatalyst is irradiated with a certain type of UV, and we make a circulation, and this is controllable with PLC system, which have been provided from Birmingham University, and this is stage of treatment of dissolved organics and others and everything which is dissolved in wastewater. So in this stage, we could remove all of dissolved organics, odor, and so on before the water goes through RO unit. And this is while working. So after, and this is the RO system, which we bought our membrane, and this is from our design in the National Science Center. And this is the RO unit is working. This is high pressure pump. Sorry. This is a high pressure pump that we use, and it is 10 bar. I think 20 bar. So this system has been built and developed from our research member and the team in Egypt. And we see here the water, fresh water produced. And this is a control unit. And this is permeate. So this system has been designed and implemented in our technological part in National Science Center. So and this is a picture of the whole RO unit based on patch RO technology and technique, where as we see, this is a control unit, and this is RO, and this is piston and the work exchanger. And as I said before, this system could save more than 40% of energy, so the cost could reduce to 40%. So now I would like to conclude my presentation in points. First, we aim to develop new photocatalytic materials and composites with sensitivity to both UV and visible light for removal of emerging pollutants or bacteria for groundwater. To develop low cost and new hybrids for heavy metals, hardness removal, develop efficient RO membranes based on polymeric materials, develop high efficiency and high recovery desalination technology for groundwater based on patch reverse osmosis, giving resistance to fouling by organic and inorganic species, demonstrates the previous mentioned solution in the study areas and disseminate the knowledge generated through the Egyptian ministries and industrial partners involved in the project. And now you see our recent publication during last year concerning water technology, water treatment, and water desalination. And this is our last publication. Also, you could see the old publications through my contacts and my Scholar Google Scholar website. Also now, this is our partners, since we have national and international cooperation, we have joint projects with many entities and universities all over the world. For example, Birmingham University in Birmingham, UK, Clean Energy Research Institute in Miami University, USA, Palermo University in Italy, University Herein in France, St. Louis University in USA, Cairo University in Egypt, Ain Shams University also in Egypt, and we have soon, I hope to have soon a cooperation with Hellenic Mediterranean University, since we are preparing to sign MOU documents with Hellenic Mediterranean University, and we will discuss to have joint scientific projects. And now I would like to thank and appreciate my Egyptian research member in Egypt in my research group, Professor Yasser Mahmoud, the co-PI of the group, Professor Ahmed El Nazer, also Professor Samir Tawfiq, Professor Rehan Rashad from Cairo University, Professor Samira Taha Rabia, Professor Salman, and also from Photochemistry Department and the NRC, Dr. Zahra Gohari, Dr. Riham Akram, from Polymer Department, Professor Mahmoud Assam, Dr. Ahmed Sayed, and from Water Pollution Department at NRC, Dr. Khulud Hamdi Kamal. Thanks a lot for your listening and interest.
Thank you very much, Hossam, for this presentation. Please stop sharing the screen to check, for the next 10 minutes if there are questions. I have some questions.
Okay.
But please stop sharing the screen and let's give the floor to the audience. If you have any questions, please raise your virtual hand in order to be able to give you the floor. Hossam, please stop sharing the screen.
Stop sharing. Okay.
Stop sharing.
I will do that. Okay.
All right. Okay. So yes, it's better. Thank you. Thank you again, Hossam, for this nice presentation.
Thank you.
So, are there any questions from the audience, or do you want me to start? Okay, I will start. Oh, Richard, yes, the floor is yours. Body language helps.
Yes. Hossam, sorry, I was trying to find the wavy thing. I couldn't. Hossam, thanks very much. Nice to hear it. I'm not an academic, so forgive me, and I'm certainly not a chemist. So quite a lot of it was going over my head. I'm just interested. You went into quite a lot of detail about the pre-treatment for the removal of copper ions. Could the same technique be used for removal of other minerals, or is that very specific to the way copper behaves?
Yeah. Thanks a lot for this good question. Yes, we have taken copper as example, but we tested for many other metals like cadmium, lead, copper, zinc, and they give the same.
Okay,
same
so
result.
you can get the same.
So,
okay, that's really interesting. And then, is it a reversible process? So could you actually use it to deliberately source, i.e. extract minerals that you want rather than minerals you don't want?
Yeah. No, just remove all divalent, trivalent metals present in water. It's not selective. Yeah.
So yeah, but the point is it's not reversible, so you couldn't use it for extracting copper that you want from.
Yeah.
No. Okay. Thank you.
Thank you very much, Richard, for the questions. Discrimination is something very, very sensitive, and it's like $1 million question even for sensing. How to discriminate, things. But let me have some questions starting from the very beginning, Hossam. First of all,
yes.
Your National Research Institute does include any research regarding photonics and lasers?
Lasers?
Yes.
Yes, we have department of laser, and we have some of our colleagues work in laser technology and laser application. Yeah.
So can you bring me in contact? Can you send me the emails of these your colleagues in
Yes.
order to start also to
Yes.
include in
Yes.
our collaboration
Yes.
this also topic?
Yes. Okay. It's my pleasure.
Okay, so now I'm going a little bit. So you are talking about the use of nanomaterials, and I would like regarding this desalination. You are using them mainly as an for their antibacterial activity, if I understood well. So I would like to ask you, what are the key performance indicators of the materials that you are looking for? So for now you are applying some materials in order to operate and remove these copper ions that I would like to reconfirm. This is mainly based on electrostatic processes. Am I right?
Yes.
So what are the characteristics of these materials or that they can be applied as for their antibacterial activity for for the purposes of the water processing? I mean, what are the characteristics of these materials? Can you?
Yeah, this is material based on some of them is based on natural polymers like ketosane and hydrogel, but and some other based on synthetic material polymers. So the base material is polymer, but we have to modify polymer to be more efficient. This modification could be done by grafting this polymer or make hybrids with another compounds like carbon nanotube or graphene. All we target is to improve the efficiency of this type of polymers. So I think this.
Okay, so Nazer, just because there are 2 points over there. You mentioned, your material to be characterized by a porosity. Am I right? So I suspect that this happens because you would like, to have the intrusion of the materials internally to your material, so to capture them, not only exploit the surface, but in case of the layered materials, let's say graphene that you mentioned, these materials are very much characterized by their very high surface to volume ratio. Am I right?
Yes, yes. We increase the volume and the surface area by using some nanomaterials like graphene. And you are right, our polymer is macroporous, so the water could go inside this polymer, and we have a good surface area and good absorption power. Yes, you're right.
Okay, so I have another question that you have. How often do you use this material? Is one use and throw, or you can, let's say, recharge them?
Yeah, we make techniques which is called backwashing. So we use backwashing to regenerate this material, and we study the durability. So this material could be used for time, and we remove it and replace it with another material. So we have studies on the durability and the lifetime for every material we produce.
And what is the capacity of these materials? So I suspect that also the recharging also is based on electrostatic. So somehow electrostatically you are removing these ions that they have been captured by your nanomaterials that they are dressed your template. Am I right?
Yeah, you're right. Yeah.
And what is the capacity of this material? How many liters of water you can treat using?
Yes. Yeah. Actually, it depends on the concentration of these metals in the wastewater, and it depends on how many the capacity of the unit. So we could start from 5 meter cube till thousands of meter cube, according to the capacity of the unit and the concentration of the heavy metals exist in water, in wastewater.
Excellent. And my last one, is like, just to reconfirm, what did I hear? You are mainly leverage and exploit the underground water in desert, or you are using this technique for the seawater?
Now, we have also we have already used for groundwater. We are now update and upgrade our system to be suitable and appropriate for seawater, because you know seawater salinity exceeds maybe reached 40,000 ppm. Groundwater maximum 10,000. So we are now updating and upgrading our system to be suitable for seawater. It's very easy that we have got more membranes and they make modification of the RO patch reactor, so it could be suitable and appropriate for high saline water from seawater.
Thank you. And how much you have lowered the cost using these techniques? How much in percentage?
Actually we aim to lower the cost for 40%.
40%.
40, yeah. So in Egypt, 1 meter cube costs about 18 Egyptian pound per meter cube. We aim to reach 8 pounds per 1 meter cube.
Thank you very much, Hossam. Thank you very much for your answers. Do we have any answer? I'm sorry. Any question from the audience? Okay. So if this is the case, I would like to thank you again, Hossam. I'm looking forward to contacting me in order to also include, these photonics groups in what we are like. And also, please, Yasser, yes.
Yes, I am working in
Just a moment. Sir. Hossam should mute his microphone because you are in the same room and the noise is like double. So, yes, please, Yasser, the floor is yours.
Yes. As you know, we are affiliated in Photochemistry Department, and I am working in photonics and laser as well. And my presentation, I prepared presentation, but the time is not available. But we have materials that could be tested under visible light and the laser as well. Yeah. So we can contact.
Yeah, I mean, we are designing right now also with the US universities a joint photonics course. So what are you doing can be a part of this course in laser applications or in light kind of applications. So please contact me in order to place you in the loop, in order to be part of this joint course that we are planning. And also students from Egypt, students from all over the world, they can have the chance to follow.
Yes, sure. I will share you some articles.
Send me an email.
And also I will contact with you. Yeah.
Excellent. So at this point, I suspect that we should finish this session. I would like to thank again Hossam and Yasser and Mirela and Professor Koudumas for the introduction and bringing you here to our community in HMU and also to the Athena European University. We are going to continue our talks. On Friday, we have Professor Kafesaki from the University of Crete. She's going to speak to us about metamaterials. So, Hossam, I have included you within the Athena Colloquia Talks speaker list, and you are going to receive whatever we are doing. Please disseminate this through your students, and let's keep in touch, as we used to say. Until next time, thank you again, and for the audience and for the people beyond, this audience. The talk will be available very soon through our YouTube channel. Thank you very much, Richard. Keep standing the cold weather, in UK, I suspect, and speak to you soon. Thank you.